Everybody, it's Tyler here, the 2022 Indiana Robotics Invitational, checking in team number 1339, AngelBotics, coming in from Colorado. Championships are an Alliance Captain, semifinalists, and personally, I think the best reveal video I pretty much have ever seen in FIRST history. Go check it out if you haven't seen it so far. Great aesthetic as well, too. We're going to be covering this full area of the robot, talking about construction style, of course, their amazing aesthetics, and everything else that's gone into this robot. And help me do more of this, I have Julia, Nick, and Diego. And as I mentioned, you got to just check out what's gone in this robot. AngelBotics, a really standout team coming in from Colorado, but starting to do really big things on a global level here first. So can't wait to hear more about it coming up here on Behind the Bumpers. This video on First Updates Now is made possible by viewers like you and also the following sponsors. Did you know that over 30% of the student population at Kettering University was in high school robotics? These same students have received a portion of over $7 million from robotics scholarships from Kettering University. See why so many in FIRST choose to go to Kettering University at kettering.edu. If you're a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many FIRST alumni are coming to Stryker for their internship or career at careers.stryker.com. Let's start out with construction style. When we're talking about pre-show a little bit here, you mentioned that's been an important thing to you. You've been doing it for a few years. So talk to me about what the general theming of your construction style is, why you chose to get away, and how it's worked out for you.
Yeah, so one of our biggest goals this year was to have a fully integrated robot as quickly as possible. And part of what made that work was our use of a lot of polycarbonate on the superstructure. So for our indexing system, our shooter, and our intake, we use almost exclusively this 1/4-inch polycarb stock, as well as our standoffs with tube nuts in them. This is really easy for us to machine quickly, and so we can put together full-scale prototypes rapidly, test them to failure, and make adjustments based on what didn't work.
When you look at the games throughout the years, have you had to kind of modify the general concept at all, or how is that molded from year to year for your team?
Yeah, so the biggest similarity, I'd say, we really started sort of doing this construction methodology in 2020. We recognized that the game pieces were very similar this year, and so that's why we sort of chose to take a similar route. Our indexer looks pretty similar this year, as well as our sort of shooter tower. So.
One of the things we mentioned with your team this year is the absolutely amazing aesthetic style you on. If you haven't seen this team, we've had them on the Open Alliance show a couple of times too, a really prominent team with the Open Alliance as well. But Julia, I just got to ask, in general, this whole thing, the 80s theming, the leggings I've seen, everything that's gone into this, what was just kind of the thought process between going that route? Because it really has been standout this year.
Yeah, so every year we have a new theme. We really put a lot of effort into our imagery, and we like to switch it up every year. So next year we'll have something different. Last year we had something different. And we were really interested. We wanted to do something decades themed, and 80s has just been so big recently that we wanted to do that. And then Jazzercise just fit right in. So our robot, Jazzy Judy, is actually named after Judy Sherbert-Missett, the founder of Jazzercise.
Cool.
So we sort of wanted to incorporate all this theming.
For you mentioned it was a decades team this year. Do you have something picked out for next year, or is it based on the game? When does that concept come out of what you're going to do?
We generally don't follow the game themes. We kind of just do our own thing. I think next year we're thinking of doing Kiss, but we'll see.
Kiss?
Yeah.
Like the Rock Band?
Yeah.
Oh my goodness! I can't wait to see that.
We'll see if we might switch it up. Generally, it's this was like a last-minute switch up.
Yeah.
We're going to do Lord of the Rings.
I'm looking forward to seeing all of you in full face paint next year. Kiss face paint would be fantastic. So we'll see the whole theme of that. Be really cool as well. Love to hear about your shirts that you have as well too, and just the custom work you've done. We talked a little about that on the Open Alliance show. I remember back a long time ago. But love to just hear more about why it's important to your team.
Yeah, so we actually made all our own shirts this year. This was really important to us because once again we really wanted to fit it with the theme. So all of these are hand cut vinyl, and we pressed it all on. So we made about 50 shirts this year, put a lot of hard work into them.
Yeah, and the overall look is just great. I love it, the amount of different layers that you have on there too. And when you're doing shirts like that, I had some experience in creating those. Are you doing screen prints or just pure vinyl, or what do you do for that?
Yeah, so we actually have a cutter that cuts vinyl for us. So we just bought sheets of vinyl, and then each of these layers we cut them out and then had to hand press them on with just a sort of
That's really
press.
cool.
Yeah.
I like that a lot. Let's start to jump into your robot here. We're going to start out with intake-wise on that for this year's robot. Tell me a little about that, and then we're going to kind of switch back and forth with Diego as we go through the robot, talking about some of the programming. But love to hear, in general, any concepts, things that maybe didn't work out, and then like how'd you wind up with like this type of material and rollers that you're using too?
Yeah. So one of the first things we recognized this year is that these balls interact well with almost any material.
Sure.
So we sort of went with this medical wrap because that's something that worked really well for us in 2020. Sorry. Compliant wheels up front just help us sort of get an initial grip on the ball and also help us maintain more even compression as the ball comes over the bumpers. One of the things we did change after our regional events was we added a retraction mechanism, so we didn't have this in Orange County. We have spools on either side here that sort of winch the intake up and down. We chose not to have pneumatics on our robot pretty early this season just to reduce complexity. So this helps us avoid those G204 penalties that we were racking up in Orange County and just increase our performance a bit.
That's really cool, the winch mechanism that you have for that. I really haven't seen that in too many other robots before. When you were testing that, like how did you get the timing down exactly to how you want it, especially the speed of like retracting and bringing in your intake so much?
Yeah, we sort of started slow and then we're almost up to full speed now, 12 volts I think on the Neo 550s. It was just a matter of testing out what worked and what didn't.
Sure.
We had to figure out how to not crush the balls and sort of destroy the spool system when they would sort of get stuck right up front there. So yeah, it just took a lot of testing.
Let's keep moving on your robot. We're going to talk about your index area, and then we're going to bring in Diego to talk about your color sensing that you have as well too. But let's talk a little about some of the mechanical features, some of the belting you're using, how that compressions work, that sort of thing.
Yeah, so we're using almost exclusively HDD belts on our indexing system, and then to bring it up through the S-curve, we have a single Coulson in the center. One thing we really like about the S-curve is that it enables us to have just this motor to feed, so one motor can bring it all the way through the S-curve as opposed to having a few, one for kicker and one to sort of bring it up and back. The HDD belts have worked really well. We don't have much compression on them at all. It's just enough to sort of hold them in place while we're driving around. Not too grippy because we don't want to jam up, even though that's not a huge problem with these balls, but yeah.
Well, let's get your robot booted up here, and then we'll talk about the color sensor that Diego's going to cover here. So let's plug in that cable, and then we'll kind of see how that in general works out. And I'd love to hear just more about from your team where that's ejecting from, how that's worked out, why you chose to go that route that you did as well too.
Yeah, so one of the things this year with our color sensor is when we intake a ball, we want to make sure that the ball doesn't go too far up through the intake. Like we don't want it to shoot prematurely, or we don't want it to get stuck really early in the intake. So the color sensor also doubles as like where in the robot our ball is. So we don't always have to time because sometimes the ball is knocking around inside the intake. So once the ball gets up to the color sensor, the indexer motors will turn off and keep the ball just right where we want it so we can load it and shoot it easily. Also, if we intake the wrong color ball, the color sensor will load it up into the shooter and just poop it out the front. And so it won't even go in the lower goal. It'll just kind of roll off the front of the robot nicely.
So it's just going to do that nice little bloop each time for that as well too. Yeah, that seems to work out great for that. As we start to wind up your robot, a couple last areas to talk about here. Talk about your shooter that you have, so we'll hear a little bit more about that. And then we're going to do a full demo of your climber sequence as well too. So tell us a little bit more about your shooter process and how that's all integrated within your robot.
Yeah, so our shooter's fed, like I said, by just that singular wheel. We're running a dual flywheel setup, so we have one main wheel, we call that like the power wheel, and then our rear wheel is like the spin or aim wheel. One thing we recognized pretty early on is that controlling backspin, mitigating it, or inducing it can really influence how bouncy the shots are into the hub. And so by tuning the relative like linear velocities of those two wheels, we've been able to get a pretty consistent shot.
Let's wind up then, and we'll talk about the climber that goes into it. And as mentioned, Diego's going to show up the climber sequence and what's happened to as well too. So Diego, tell me about what's gone into the climber, and I'd love to just hear the how you went about doing the programming work to get that climber sequence working at the level you need to.
Yeah, so the general idea behind the climbers is that these the side arms can rotate around and go around the bar as the static arms get pushed in. So what these dynamic arms are going to do is they can rotate back around the bar and they'll slide down into these hooks and then click in, and then we can send up the dynamic arms for another rung. And we just continually keep doing that until we get to the traversal bar. And the nice thing about our arms is that we've programmed very specific positions. So we can send the arms through an automated climbing sequence and just climb up the bars, not with too much driver intervention. Of course, if something goes wrong, we can always fall back into manual control. But the automated climbing sequence has definitely made climbing really fast.
Well, can we see that deploy and narrate that through as it's happening?
So when we first go up to climb, we go in manual climb and just send up the arms, and then we're going to drive back into the first rung, and then we pull up and start the first climbing sequence. So the hooks would have clicked in by now, and then we start the automated climbing sequence. So we get sent up, send them back. So now they're going to be touching the next rung, the high rung, and then now we start to pull in, and then we do the exact same for the traversal rung.
And what's the general timing for this? And then when you were approaching the game, what was kind of the initial thought process how quickly to do it?
Yeah, so some of the timing this is actually going to be a little slower on the rungs because the robot actually has to pull itself up. Also, we put the Falcon 500s into brake mode, because if we don't, the robot's really going to start swinging. So something that we did a lot of before champs was making sure that the arms would absorb a lot of the swing, and so we wouldn't bump into the bars and hop off.
Perfect. Well, AngelBotics, thank you so much for taking the time to tell us more about your team. Really the complete package here, and I love seeing that team that's just composed so well, not just a robot, but as a team in general. So thank you so much for that. Thanks for your contributions to the Open Alliance as well, too. And we wish you best of luck here at IRI. And, of course, can't wait to see you in future years as well. Thanks a lot.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Did you know that over 30% of the student population at Kettering University was in high school robotics? These same students have received a portion of over $7 million from robotics scholarships from Kettering University. See why so many in First choose to go to Kettering University at kettering.edu. If you're a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.